So first of all, warm wishes to everyone on the World Food Day 2023. So it's indeed an honor and privilege of IARI that today we have with us World Food Prize Laureate and one of the world's most respected soil scientists, Padma Shri Professor Rattan Lal ji, who has kindly consented to deliver the World Food Day lecture. So we are all aware about his pioneering research on restoration of soil health and One Health concept. And today it is indeed a great opportunity for all of us to gain newer heights on this topic and imbibing some of the core human values from his humble and inspiring persona. So with these few words, may I now have the pleasure of inviting Honorable Dean and Joint Director Education IARI, Dr. Nukma Singh ma'am, for her welcome address and a brief about the World Food Day. Thank you.
Thank you, Dr. Dahuja. आप सभी का हार्दिक अभिनंदन. Warm greetings to one and all. Respected speaker of the World Food Day 2023 lecture at IARI, Professor Rattan Lal ji. Event chair, the chief patron of IARI Alumni Association and Director IARI, Dr. A.K. Singh sir. Worthy alumni, NAS Fellowship, colleagues from ICR and IARI, faculty, staff, and my dear students. It's a cherishable moment for the entire IARI family to have with us the renowned IARI alumnus whose mention on the World Food Prize Forum in 2020 website as Soil Health Trailblazer, honored as 2020 World Food Prize Laureate, swelled our hearts with pride and joy. And he's here with us. Welcome all to the World Food Day Lecture 2023, being organized jointly by IARI Alumni Cell and the IQAC, the Internal Quality Assurance Cell of IARI. As my duty, I request your kind attention on a brief about the World Food Day. World Food Day, one of the most celebrated days in UN calendar, is marked on 16th October each year. It commemorates the founding of UN's Food and Agricultural Organization, FAO, in 1945. Spearheaded by the FAO, this day is dedicated to raising awareness about food security, hunger, and agricultural concerns on a global scale. Throughout 16th to 20th October this year, FAO headquarters in Rome will be having an assembly of world leaders, experts, change makers, youth, and indigenous activists to participate in the structured events at World Food Forum, Rome. Celebrated across more than 150 countries, the event will serve as a rallying point for governments, businesses, civil society organizations, and the public to collectively combat the hunger concerns and raise awareness about the profound impact of responsible water management in our agri-food system. This year's theme, Water is Life, Water is Food, Leave No One Behind, spotlights the plight of 2.4 billion people in water-stressed countries and 600 million reliant on aquatic food systems who face pollution, ecosystem degradation, and climate change impacts. With this, I now request the chair of today's event, Dr. A.K. Singh sir, the Director IARI, to kindly conduct further proceedings by welcoming and introducing the speaker to the audience. Thank you, sir.
Please unmute.
Yes.
Yeah.
Thank you, Dr. Nukma, for a brief on World Food Day, and also for your initiative to take up this very important activity involving one of the most distinguished alumni of IARI to initiate the series of lectures that we are going to have henceforth. Very good morning, sir. You there? I am at Manila attending the 6th International Rice Congress. And what a day today that this whole day we had discussion on, MRV technology, which really looks into the measurements, reporting, and verification of greenhouse gases, and how this technology can help, bringing accuracy in measurement of emission pattern, and then the financial arrangements and the support which are going to flow in for this particular activity from different corners. You have been a champion of taking care of soil health, and that is a subject core to your heart, and we are indeed grateful to you for agreeing to deliver this important lecture today. We are joined by almost 300 participants online. And for the benefit of the youngsters, particularly our graduate students who have joined very recently, as you are aware, sir, we have started the undergraduate program also at IARI. I would like to briefly tell about Professor Rattan Lal, the speaker for today, who did his master's in soil science and agricultural chemistry from the Institute, and that was way back in 1963-65. And then he obtained his PhD degree from Ohio State University in 1968. Currently, he is a distinguished professor and director of Carbon Management and Sequestration Center at the Ohio State University. And his research areas include adaptation, mitigation of climate change, soil carbon sequestration, climate smart agriculture, sustainable management of soil, global food security, soil quality, soil health, soil water management, erosion control, and soil structure. Professor Rattan Lal has several honors and awards to his credit, including International Soil Science Award from the Soil Science Society of America, and also to honor his distinguished contribution to this important field, Government of India bestowed upon him the Padma Shri Award. He's fellow of many important science academies, including National Academy of Agricultural Sciences and the Third World Academy of Science. He's also adjunct professor of IARI, and is always, ready to take classes. Unfortunately, we have not been able to make use of his expertise and availability all the time because his heart beats for IARI. We are indeed very grateful to you, sir, for agreeing to be part of this important lecture series today, and I thank you for agreeing to this, and we look forward to hear your great presentation. And with that, I would like to thank each one of you, those who have joined us online, all the distinguished alumni of IARI, faculty members, students. It's a great beginning today, and we will continue this series with, very frequently organizing lectures from distinguished alumni and other distinguished scientists in the field. Thank you very much, sir. And with that, I would like to request you to kindly deliver your talk. Thank you.
Thank you, Director Singh, Dr. Anupama Singh, and Dr. Tapan Jyoti Prakasta, colleagues, friends, ladies and gentlemen. It's indeed a great honor for me. I am based at Ohio State. I'm director of, now this center is named Rattan Lal Center for Carbon Management and Sequestration. It's a great honor for me. We also have established a Rattan Lal Endowed Chair in Soil Science. And the reason for that was many awards that I was very privileged to receive. They totaled about $1 million. And I gave $1 million to Ohio State. And therefore, they have named a professor position, Rattan Lal Endowed Professor. So we have Rattan Lal Center and Rattan Lal Endowed Professor. And this is because I am graduate from the great IARI institution. It's one of the greatest things that ever happened to me. I also want to congratulate you about the moon landing of Chandrayaan-3. That makes us all very, very proud. So India is really now among the leading scientific and space nations of the world. So with all that, I wish you all a very, very happy World Food Day. It has already been said it was established on 16th of October in 1945. That's the day the FAO, Food and Agriculture Organization, was created. And FAO, along with the World Food Program, along with the IFAD, it's WHO, World Health Organization. This is celebrated, and every year the theme of the World Food Day changes. 2014, it was family farming, feeding the world, caring for the earth. As an example, 2015, it was social protection and agriculture, breaking the cycle of rural poverty. 2016, climate change. Climate is changing, food and agriculture must do. And right now, the title, as it was introduced by Dr. Anupama Singh, water is life, water is food, and leave no one behind. So theme is chosen every year. So that gives me the reason to share with you very briefly the water resources of India. And the total precipitation average is 1170 millimeter per year. That converted into kilometer cube of water received is 4,000. And that, if you divide by the population of India, roughly 1.4 billion, come to about 2,700 meter cube per person, which is on average very adequate amount, because what we need per person is 1,000 meter cube. But it's not equally distributed. It's unpredictable sometimes. So we harness out of 4,000 kilometer cube received as a precipitation, we harness only about 370 kilometer cube, less than 1/10. That means water resource management could be very important. Irrigation water, we use 688 kilometer cube of water. So water indeed in India is a very precious commodity. Looking at from the population perspective, human population in India is 18% of the world population. Land area of India is 2.4% of the world land, and water resources of India are only 4%. So 18% of the world population is living on 2.4% of the world area, and 4% of the water resources of the world. So India has a challenge of meeting the basic necessity. In addition to livestock, India also have 31% of the world livestock, which is almost a billion cattle population. So which all have a strong need for sustainable management of water resources. India had done tremendous progress in increasing area under irrigation. Right now, it's almost 70 million hectare, which is irrigated primarily by traditional method, flooding and furrow irrigation, and now sprinkler is coming up. But I'll come back to that in a moment. Perhaps there are better ways of using water than flood irrigation, which is about 5,000 years old procedure, the technique. Water productivity is a key factor, especially in India, because water productivity is a kilogram of grain per unit of water use. So increasing water productivity, that means more crop per drop, should be the key strategy. And soil being the largest reservoir of green water globally, managing soil water, which really means storing water where it falls, is critical. So in that regard, soil health, and I'll briefly explain that, is very critical to improving the water productivity and at the same time mitigating drought. Talking about drought, we should know that there are 6 types of drought. Therefore, understanding what particular drought a given region is suffering from. Meteorological drought is a long-term deficiency of precipitation. Hydrological drought is a decline of water in rivers, reservoirs, and aquifers. Pedological drought is a reduction in soil water storage. That's where soil health comes in. Agronomic drought is low availability at critical stages of crop growth. Ecological drought is a low water availability by land use conversion. And sociological drought is a demand of a community which exceeds the supply, and that leads to water deficit. So characterizing what particular type of drought a region is suffering is very important to solving the drought problem. And from that point of view, diagnosis of the type of drought is very, very critical. And we should also remember that the soil, people sometimes misnomerly, not correctly call it dirt, is the best filter to purify the dirty water and denature pollutants. And then a question is, how do we transform water from one pool of water to another? And different types of pool are blue water, that's the water you see in lakes, rivers, streams, rainwater, ocean. And green water is the water stored in the root zone on which all plants grow. And gray and black water are the water contaminated by human use. So how to convert gray and black water and use it in the soil, and how to convert blue water and increase green water supply is really very, very critical. And then we have a virtual water. So there are types of drought and the types of water. You notice there are 6 types of drought, and I have listed here 5 types of water. So matching them to make sure we are improving the green water supply. Virtual water is the water which is contained in a product like wheat and soybean and corn and chickpea and cotton. And so if you export those things from one region, one place, one country to another, you are actually exporting a lot of water. So that's one of the policy consideration we should think about. Paddy rice, obviously rice wheat system in India is the basis of green revolution for producing cereal. But growing flooded rice by puddling and then flooding it is probably need to be reconsidered. Can we talk about aerobic rice? Just like we grow wheat and barley and sorghum and millets. Yes, yield may be less, 10%, maybe 15%, maybe 5%, depending on variety, soil type. But your saving of water, saving of natural resources is a very, very critical part. So something we need to think about that. The other part which I like to mention is going back to our, and I'm going to talk a little bit more today about our culture and our Sanskriti and our civilization. Kshati, Jal, Pavak, Gagan, Samira, Panch Tattva, Adam Sharira, human body made of 5 elements, and water is one. And yet at the same time, we suffer from flood. And there is not a single year where India, this summer we had Assam and Indo-Gangetic plains suffering from flood. The cause is the lower Shivalik hills, Himalayan hills are all denuded. So, but part that we need to remember is that the flood, when it happens, drought will happen at the same place, because flood and drought are 2 sides of the same coin. So you have flood, water did not get into the soil, it did not become from blue water to green water, and as the rain is gone and soil dries out very quickly because water was not stored, you have a drought. So please understand that drought and flood are 2 problems caused by the same reason, and the reason is misuse of land and mismanagement of soil. Therefore, water is lost and not stored as a blue water converted into green water. Here's another picture I want to show you. Plowing field, you notice the plows. And this comes from Harappan. I got this slide from British Museum, 3200 BC. We were planting crops in lines. We were plowing. That is 5,000 years ago picture from Indus Valley. And I think we need to think, can we somehow translate the agricultural profession to modern innovation? Can we do in a way that agriculture become a solution to the environment? That's really the key. How to make agriculture not just a medium to produce food, but also a solution to improving the environment, especially flood and drought, and of course, water quality. That brings me to the question of farming carbon. You know, you probably have heard farming wheat and farming rice and farming cotton, sugarcane, vegetable crop, apple, horticultural crops. We want to farm carbon, which means we are going to grow carbon in land, in soil, so that it can also generate income for farmer. Just like growing rice and wheat and sugarcane generates income, can growing carbon in soil generate income? So my hope, my desire, my goal is to make carbon a new crop of this era, so that farmer can buy and sell. And I'm glad that our director in Manila, they are talking about measurement, monitoring, and verification, very important part. But I have another suggestion. Rather than going in the direction of measurement, monitoring, and verification, and if the farmers are to pay the cost of that before we can buy their commodity, they will not get much. So I hope we do something else. So what's farming carbon? Growing carbon in soil as a commodity, which can be bringing income for farmer. And the reason for that is most soils of India cultivated for millennia have lost probably as much as 75% of their original soil organic matter content. Therefore, these soils are depleted, they are degraded, they cannot hold much water. Irrigation does not have good efficiency. When you apply fertilizer, it's either leached out or washed away or volatilized. Efficiency of nitrogen may be hardly 30%. So we need to restore soil organic matter content. And I mentioned how much the farmer should be paid. My calculation is $50 or about 5,000 rupees per acre per year. And this is not necessarily based on measurement, monitoring, and verification. It's needed. That MMV is needed absolutely, so that we know what is happening to soil quality and soil health, but not for payment for ecosystem services. That should be simplified. Make as simple as possible. Do not put any monkey wrenches in it where farmers do not get paid properly. So what would I suggest? Satellite imagery. If a satellite picture shows that the farmers are not burning the residue, they're not plowing the land, they are keeping the residue as a mulch, they are following complex rotation, they are using manure, we know what the rate of carbon sequestration they have for that particular region. Paid. Using satellite, paid. But measurement, monitoring, verification should continue to get every 5-year soil health report for the nation. Yes, but not as a system to pay farmer. Simplify that, make it as simple as you can. We have an issue of water quality everywhere, River Yamuna, and under better conditions, when the industrial effluent is not put into it, the same location looks so beautiful. The beautiful India Gate, the same on a nice day after rain, should look like this. River Ganges, having a lot of biodiversity, even dolphins, which you rarely see. It is really a very beautiful thing to have. So we need policies which rejuvenate soil health, and soil, water, and air, they go together. You cannot improve water without improving soil. You cannot improve air without improving soil. So soil, water, air are the trinity, which are very important. They cannot be separated, and we should not. So policy on soil health, I would hope that India has a Soil Health Act. And under that act, which is a soil-centric program, promote conservation agriculture, integrated nutrient water management, drip sub-irrigation, not flood irrigation, restoring watershed, aerobic direct seeded rice, and create policy, political instrument which pay farmer, as I said, 5,000 rupees per acre per year for ecosystem services. And under those, we could classify several do's and don'ts in India, adopting conservation agriculture as a do, recycling of crop residue, not burning it, recycling animal waste, also not burning it, providing clean cooking fuel to rural community, protecting prime agricultural land against urbanization, map out top quality land, and that will not be changed to anything. Planting trees on hills greater than 7% slope, that will be entire lower Shivalik hills from Kashmir all the way to Nagaland and Assam region area. They are all denuded. That's why we have flood drought problem. Revising curricula, like in college, your college, I'm very glad to hear from the director that we have undergraduate classes now at IARI. Curricula should have environmental education as a very important part. Paying farmer for carbon, I mentioned already, encouraging religious organization, and I'm going to take a few minutes to explain what I mean by that. Increasing dialogue with policymaker, and there are many don't also. No burning of residue, no flood-based irrigation, no removal of topsoil for brick making. I know what you're going to say. How do you build rooms and how now? India being a space age, leading in the world, yes, sure, we can find alternative to construction material rather taking fertile topsoil for 1 meter for brick making. Broadcasting fertilizer should not be permitted. Plowing of puddling of the soil should be banned. Traditional fuel, cow dung, crop residue, wood replaced by modern fuel. Grazing should be controlled. Storage of grain properly so that we don't waste food, 30 to 40% of it. Subsidies for flood irrigation and nitrogen fertilizer should be changed into payment for ecosystem services. And of course, residue should be managed very, very properly. So here is some kind of a roadmap, if I may suggest. Year 2017, 70 million hectare under irrigation, but using 200 kilometer cube of water because of flood irrigation, sprinkler irrigation, furrow irrigation. By 2030, let's increase that area to 75, but reduce water use because changing from flood to drip fertigation. 150 kilometer cube. By 2050, 100 kilometer cube. By 2100, increase the area to 100 million hectare, but have only 75 kilometer cube of water use. You're improving the efficiency. Same thing applies to fertilizer. We use now 30 million tons of fertilizer. If we improve soil health, fertilizer use by 2050 should be only 60, 70% of what we use now. And by 2100, only half of what we use now. Improving the efficiency. The focus, I'm a member of the board of International Fertilizer Development Center, and the same idea I talk about the in-field burning of residue should be banned immediately, nowhere. So it's a payment. You don't burn the residue. We can see it by satellite imagery. You will be rewarded for that practice. Pesticide use, we have 56,000 tons at the moment. It should come down to 1/6. Some pesticides are going to be needed. These pesticides and fertilizer are going to be used as medicine. And you know the difference between medicine and poison? the dose and the time of application and the method of application. One aspirin can cure headache, and you know what people do when they take 100 aspirin. Same thing, these chemicals, they have to be used as medicine, not a luxury of broadcasting it as wish. And we can yet double our productivity. And we can reduce post-harvest losses. So on this World Food Day, we should really make some kind of roadmap for each kasbah, for each tahsil, for each jila, for each province, state, and for the nation. A map that we have a goal how to preserve, how to reduce the use of chemicals, food waste, water, and improving the efficiency. That should be. Now I want to finally say something about our culture and our Sanskriti, because we always talk about science, but I think if we should, so nature is God. Bhagavad Gita says the same thing. When Arjuna asked Lord Krishna, who are you? When he explains who I am, essentially, if nature is God, then nature must have rights, rights of nature, rights of soil. Soil is a living entity. Like any other living entity, it must have rights. And I think that's what we want to talk. So Ganges River, our culture, of course, Lord Shiva's jatas, where the Ganges mythologically originate, and then goes to east, where it meets the son of Brahma, Brahmaputra, at the Sundarban. And most beautiful Sundarban, along with the tiger as the homage, national park, which are more beautiful place because of that. Then our Upanishad, our habitat is viewed as an abode of experience. Bhogasthana, nature, Prakriti provide this physical and biological setting that all sentient beings use. Hence, it must not be ruthlessly exploited. Thus, humans must take a spiritual journey from non-being to being, from darkness to light, from death to deathlessness. And that is what our culture talks about nature. Then the karma, the law of moral order. This is relevant to the question, how is the occurrence of a phenomenon to be explained? Karma gati. It's argued that no event in the natural or moral context is possible without dependence on some other faction. And in this context, A.L. Basham observed, we cannot escape the law of karma any more than we can escape the law of gravity. And what are the law of karma? This is relevant to the question, how the occurrence of phenomena to be explained in natural and moral context. And in the context in which reincarnation is also the law of karma. Karma is the law of action and reaction which governs life. Karma is a natural law of life, just as gravity is a natural law of matter. Karma refers to totality of our actions and their concomitant reactions in this and all previous lives, all of which determine our future. Nothing comes from nothing. Ex nihilo nihil fit. That's Latin. But in the Upanishad tradition, it is stated, nasato vidyata shave. From no being, being cannot arise. From no being, being cannot arise. And that's exactly what the Latin says. Then there's a question of evolution and involution. What was the seed? It was the same as the tree. All the possibility of a future tree are in that seed. All the possibility of future man are in the little baby. All the possibilities of any future life are in the germ. And what is this? The ancient philosophers of India call it involution. I don't think Darwin knew this philosophy when we talk about evolution. We find then that every evolution presupposes an involution. Nothing can be evolved which is not already there, and that's involution. As such, evolution does not come out of zero. Then where does it come from? From previous involution. The child is the man involved, and the man is the child evolved. The seed is the tree involved, and the tree is the seed evolved. All the possibilities of life are in that concept. Then we have Patanjali on evolution, Vedic theory of evolution, and of Aksha, Prana, and Sankhya philosophy is exactly what the Darwin theory of evolution. But he didn't know about it, so we must give him that credit. Patanjali speaks of one species being changed to another. Prakirtya prana puratam. One life form changed into another form. However, Patanjali differs from Darwin in the explanation of Patanjali's evolution is spiritual. That's the difference. So what are the spiritual belief of water? I already mentioned Kshati, Jal, Pavak, Gagan, Samira. Jal, obviously very important. In Sikhism, it really says very nice, Guru Bani, Paun Guru Pani Pita, Dhart Mata Mahat. That's a Paun Guru Pani Pita, Mata Dhart Mahat. Islam, he created the man of clay, like the potters. Surah Al-Rahman, we made from water every living thing. Quran 25:54, do not overuse water even if you are on a running river. That says everything. So we really go back to also our scriptures of all our religion, including Buddhism, Jainism, Sikhism, Islam, Hinduism, and bring that with modern science, combine the two together to address this issue. And finally, I would like to leave the message for our distinguished guest today present from Maha-Upanishad, which says, Vasudevaya Kutumbakam. World is one family. This is mine, that is his, say the small-minded. The wise believe that the entire world is a family. Very happy World Food Day. Thank you so much.
I request all to unmute their mics and give a applause for the humble words, other means I would say the phenomenal words of wisdom that we had from our speaker of today. Thank you, everyone. Thank you, sir. Maybe now have
So,
as
Dr. Nukma, I think there could be some questions. I think we can take question and answers.
yes, sir. Because I was going to say so. So now I request, rather encourage our dear students to kindly ask whatever they want from Professor Rattan Lal ji. So, sir, if faculty is raising their hand, so can I just?
Please, yes.
Go ahead, yeah.
Yes.
Okay, so Dr. D.K. Sharma, Professor, the Division of Environment Science.
Thank you. Thank you. Thank you very much, sir, for your enlightening lecture. So, sir, you mentioned about the payment for ecosystem services by carbon sequestration. In India, we have a problem that we have 86% small and marginal farmer. Of course, in some part of Punjab and Haryana, there are some NGOs working on that aspect. So, sir, what are the challenges of carbon sequestration or payment for ecosystem services for a country like India?
Well, small farming is one issue. Cannot survive. It will be very difficult to have good productivity. And this is where One Health concept is. I think during the introduction, it was mentioned, the One concept. And the One Health concept these days, from the COVID time, people are focused primarily, the medical profession and veterinarian, how to link human health to animal health. But One Health concept in totality is the health of soil, plants, animal, people, environment, and the planet is one and indivisible. I'm proposing a class to be taught on One Health. I think this is a concept which will, that health of soil is the basis of health of everything that lives on it, including the people. And So the medical cost skyrocketing, all kinds of diseases happening because of water pollution, because of air pollution, because of soil contamination. It's really something that should be addressed in teaching One Health concept. I hope now that your undergraduate program at IARI, the One Health class should be the basic class, very beginning in the year of starting undergraduate program.
Thank you, sir.
Thank you. So can we have one more question?
May I have a question, madam?
Okay, sir. Professor Tapan Prakastha from Soil Science, yeah. Because sir is also, yeah.
Yeah, also I am from the same division where you did master's program, sir. So I have a
Yes.
question, sir. You know very well that in Punjab and Haryana, the burning of residues is really a problem. So to your view, what should be the best solution for that?
Well, I mentioned payment to farmer for ecosystem services. That's one. Second, technology. They are burning because the window between rice harvest and wheat planting is very short. And during that time, even 1 day delay in sowing of wheat, because the heat wave in March begins very soon at the grain filling stage, so grains get shriveled, yield decreases, the quality of the grain is affected. So farmers, if they do not have any technology to take care of residue properly, then of course match is the only weapon they got left. So somehow technology, how to seed effectively and properly through wet residue of wheat, how of rice, how to use some residue for other purposes such as mushroom production, maybe composting, maybe biogas, but everything goes back on land. Rather than burning in a traditional way, how about using residue to produce syngas, syn oil through pyrolysis and produce energy, and yet the biochar which is left back fortified and put back on the soil. I think those are the kind of alternative, innovative technologies which have to come up. And if those technologies are not given access to farmers and they are not motivated to save this very precious quantity and burn it, is not really going to happen. We should also study what happens when the burning is there. The burning flame, its temperature changes from the ground level to the top of the flame. The composition of gases being emitted is different in different levels in the flame. And this heat wave also is transferred into the soil and maybe to 50, 60 centimeter depth. So what is happening underground? We must document all those things and let farmers see what damage they are doing to their own environment and their own health. I think it's not the coercion part. You don't want farmers to march with their tractors again at Delhi. We want to have a dialogue with them. We want to let, for example, many times people ask me, who is your boss? My boss is farmer. I hope my dean and department head are not listening to that. But we are servant of farmers. We should make sure they understand we are there to provide them the support and guidance. Once they trust us, the scientific community, I think they will do what we tell them to do.
Yes,
Thank you very much, sir.
yeah. May I request now Director Sir to
I think Dr. Anupma, there are a few more questions. Maybe you can take them and then I will
Okay.
add a few things.
Fine. Fine, sir. So here is one question from Dr. Usha. How to remove heavy metal contamination from composts? Rattan Lal,
That's
sir.
a very important question. The compost, heavy metal, lead, mercury, arsenic, that is really, and I think what the source of heavy metal? The source of heavy metal is not crop residue, obviously. The source of heavy metal is industrial pollutants, urban pollutants. So somewhere the system of urban village Kasbah collection of the waste material from industry, from human waste, and from they have to be separated in such a way that heavy metals are taken out of those before the waste material is returned back to the land or river. I showed the picture of Yamuna with that foam. Obviously, that's the industrial way. That's also full of heavy metal. So it really goes back to urban planning, where the industrial waste and human waste cannot be mixed into the environment. Then somehow or the other, it gets back on the land, either as a compost made from that human waste or industrial waste. So this somehow stop the heavy metal right at the place of the origin, separate them out. This means replanning of our city waste disposal system very carefully.
Sir, here's another question. How long the sequestered carbon remains in soil?
Oh, the mean residence time of is very common question. First of all, I should explain what a mean residence time is. So let's say IARI has 2,000 students, and IARI now with undergraduate program is graduating 500 every year or 1,000 every year. So total pool of students divided by the number of students that graduate every year give you the mean residence time that the students stay at IARI. Ohio State has 60,000 students. We graduate 15,000 every year. So 60,000 divided by 15,000 per year, mean residence time is 4 years. So going back to the soil carbon is a total carbon pool in the soil divided by the flux. And total pool is total carbon, organic and inorganic, let's say up to 1 meter depth. And the flux is the amount of carbon transported either by emission of CO2, CH4, or loss by runoff or wind. So take the pool and divide. These are the simpler way to calculate it, but there are other way of carbon dating and so forth. If the soil is not disturbed, remember I said do not plow, leave the crop residue back on the land, do not puddle the soil, change the way the farming is done. I showed picture of plowing in Indus Valley 2000 BC. So we got to change that. Then where will the carbon go? You can find carbon in protected soil under forest, which have been there for thousands of years. So mean residence time is shortened when soil is disturbed, plowed, and when the soil organic matter content, which is the heart of soil health, is used as a source of nutrients, and you're not putting nutrient properly. That is when it happens.
So,
Hello,
sir,
good afternoon, ma'am.
here is probably the last question.
Ma'am, I have
Please, 1 minute. Sir, your views on, please post in the chat box. Please, Rattan Lal sir, your views on natural farming and the zero budget farming in Indian agriculture have been requested. Although this is something, an issue.
No. I had the honor to, in July, I think, or June, I had the honor to meet the Honorable Prime Minister, Mr. Modi, in New York when he was visiting the US. And he asked me the same question, what is your view on natural farming and zero budget agriculture? And I said, sir, that's what we were doing before the fertilizer came in 1960. And, in 1947, population of India was 330 million. Food grain production was 50 million ton. Now population of India is 1.45 billion, and food grain production is 320 million. Food grain production has gone up by a factor of 6.25, and the population has gone up by a factor of 4.25. So Malthus has been proven wrong. And why this productivity has increased so much? Because we follow the law of return. Please remember, soil is a bank account. In a bank, you cannot withdraw more than what you deposit. And this is called law of return. Whatever
From HUD protection, Chrysler, kindly mute your mic, please.
So the law of return states that anything taken from nature must be returned back to it at the same place. Now, then they talk about zero budget agriculture and or zero emission agriculture. This is correct for industry. If you are a tire factory or car manufacturer or electronic manufacturer or manufacturing machinery, yes, you want to become zero emission. Agriculture, no, we want, if we invest 1 ton of carbon in fertilizer, irrigation, pesticides, energy, another, we want to harvest 10 ton as productivity, not 1 ton. So this zero emission agriculture has to be net negative emission by a factor of 10. You put in 1 and you take 10 by photosynthesis. So this is a misunderstanding. I'm not sure that in a short time I was able to have in-depth dialogue with the Honorable Prime Minister, but I hope that I conveyed him, no, we have to have judicious use of inputs, not a wasteful use. Use these inputs as a medicine and use agriculture as a medium to draw CO2 from the atmosphere 10 times more than what you put into it. Not 1-to-1. That's a negative emission farm. So I'm sorry, with 1.4 billion people destined to be probably closer to 2 billion by the end of the century, you can't afford that rule.
May I request Chair to kindly guide me as to,
Yeah,
because
I think, yeah, Dr. Anupma, maybe what you will do is that, or what you can do is that you can note down these questions and you can post it
yes,
to
sir. Yes, sir.
Professor Rattan Lal.
You can
And,
send them to me.
he will definitely, yeah, because we may be constrained with the time. And so, sir, thank you very much. And this was a wonderful presentation, and particularly your views on God and nature and how two are connected, and we have to respect nature as much as we respect God, and that, I think, we'll take care of many of the problems. So here at International Rice Congress, this is the most important discussion going on, because people see a lot of money in carbon credit, carbon farming. The projections are being made that the export value of carbon credit may exceed the export earning from commodities like rice and wheat. And therefore, a number of finance companies and their financiers, their finance managers, they have made a couple of presentations. I wish there was someone like you to come forward and say straight away that I think if we see money, we should see money to help out farmers rather than exploiting them for this purpose. A lot of initiatives, of course, have been taken. IARI is involved in this area with Grow Indigo, which is a joint venture of Indigo from America and Mexico, and in promoting carbon farming in Punjab, Haryana. And the initiatives like, the production of bioethanol, compressed natural gas, briquettes, electricity generation, these are in place. And if you travel at this point of time in Haryana and Punjab, you will find a lot of big balers baling the paddy straw after combined harvest and taking it to electricity generation plant. In Punjab itself, there are about 18 plants of about 13 megawatt capacity each for annual electricity production. So those things are coming up, I think, in times to come. And then, of course, the in-situ management, enriching carbon, whether it is super seeder, happy seeder, or incorporation followed by Pusa decomposer, those kinds of strategies. And then we did one, satellite imagery that you mentioned, to ascertain the claim of a farmer on the platform where he is registering to say that I am following a practice like no burning of paddy straw or direct seeded rice or laser leveling. And my colleague, Dr. Sehgal, was able to use the data from 7 satellites for Punjab and Haryana and verified the claim of farmers, the coordinate that the farmer has claimed, and also by ground truthing going to those locations. And the correlation between these two approaches is almost 95%. R square, that's pretty good. So that gives confidence to companies that someone is coming on platform and making a claim is a genuine person, and person who is claiming also knows that if I do mischief, I will be under the radar. So those things are, I think, coming up slowly. And the very important point that you made, sir, is about the proposal of having a Soil Health Act. And I would request you to kindly write to Honorable Prime Minister on this, because soil is very dear to his heart, and he has initiated many programs, including the Soil Health Card. But in form of act like National Food Security Act came, and that act is helping 80 crores people in the country to get 35 kg per month of ration. Had there not been this kind of provision in the act, it would not have been possible. So probably if you write, your words would mean a lot to Honorable Prime Minister. Another point that you mentioned about the virtual water, which is going in form of commodities, for example, wheat export, rice export, and cotton export. So there I have a little confusion, and this I always raise this point on several forums. Like when we say, by exporting rice, India is exporting water. And, the export of rice is to the tune of 28 million tons now, about 5 million tons basmati and 21 million tons non-basmati. But actually, the rice that goes outside country has got 8% moisture in terms of real water that we see. We say 4,000 liters of water for 1 kilogram of rice, but I say it is 8 gram of water for 1 kilogram of rice at 8% moisture. So blaming, saying that way is something which is not, although we know that the fact is that the Punjab water table has declined from 10 meter to 30 meters within a span of 30 years from 1970 till now. But then this analogy of exporting water is somewhat not convincing to me. So I would request your, comment on that. But this has been a great lecture, and we really benefited, all of us, sir. And thank you so much for sparing time.
Can I just make a brief comment and then,
yes, sir.
This Health Act, if I am given an opportunity to work with ICR and Prime Minister's office, I'll consider myself highly privileged and blessed. But somebody has to provide me the opportunity to do that. The reason I mentioned I'm going to Guyana tomorrow, in fact, about 2 weeks ago, I was talking about Soil Health Act to the Ministers of Agriculture of South Americas. I was in Costa Rica, and all the Ministers of Agriculture were meeting, and I gave a talk. And at that talk, there was a Minister of Agriculture of Guyana, and he came to me and he said, I just talked to the President of Guyana after I heard what you said. We are having all the heads of state of South America meet in Guyana on 20th of October. Can you please come and repeat the same lecture, what Soil Health Act is, how to implement it. So that is why I'm going there. If I'm asked to come to India, obviously I'll be more than blessed to serve my motherland. So, but there is a need for Soil Health Act. Our soils are being depleted, polluted, removed for brick making, for any purposes, and that is our most precious resource. So Soil Health Act is not to punish anybody. Soil Health Act is to reward those who respect soil. And then everybody will follow. So it's a positive thing, it's not a negative thing. So I'm hoping US will have a soil, in the US we have a Clean Air Act, we have Clean Water Act, 67, 72, there is no Healthy Soil Act. So I'm really I'm hoping that I will have tomorrow or day after talk to heads of state of South America, 34 countries. And they told me that they are going to implement it soon. We need to do the same thing. As far as the virtual water is concerned, I'm not concerned. I think what your analogy was, I fully support it. The only part is that for growing rice, rather than growing through flooding and through puddling, which requires a lot more water, and even now you cannot plant rice in Punjab, Haryana until a certain date. So this summer, hard time is gone. So growing more rice per drop of water is a philosophy to reduce the virtual water use. And we can save tremendously. So the idea is not to maximize production, let's say 5 tons of rice paddy. I would be willing to take 4 tons if I save a lot of water. That way the virtual water used to produce becomes much less. So it's a conserving water, improving its use efficiency, conserving fertilizer, improving their efficiency. It is this concept of producing more from less. Then you reduce the use of resources and those parts. But all of those things really require leadership such as yours. And it has been very kind of you to spare time from your meeting in Manila. But please let them know that an alumni from IARI, Rattan Lal, will be willing to give. I am at the moment against trading carbon because we do not. Who will benefit? The dalal, intermediate, not the farmer. And we want to have a system where farmer benefit. 90% income goes to farmer, 10% to intermediary, not the other way around. And I think that
I will certainly do that, sir. Tomorrow at the next opportunity, I will do that.
I'll be very, and you know, like I'm talking to you in Delhi, I can be talking to people in Manila. There's no, these days modern innovations are so good. I think we have to go that route so that most reward goes to farmer, not to the middleman. Thank you, sir. Thanks so much.
Over to you, Dr. Anupma.
Thank you, sir. Thanks a lot. May I now request Dr. Dahuja to proceed further towards the conclusion of this meeting.
Yeah, thank you, ma'am. So it is my proud privilege to be offering the vote of thanks to acknowledge the help, support, and guidance received from the different corners for the successful organization of this program. So at the outset, I would like to thank the Honorable Speaker of the World Food Day lecture for his informative and captivating talk delivered in the most lucid and humble manner and linking science and spirituality. So, sir, thank you so much for agreeing to our request to deliver this memorable lecture. My sincere thanks to Director, sir, who, despite being away from Delhi for a special assignment, made it convenient to chair this program and guiding us all through for its flawless organization. So my thanks are also due to the Dean and Joint Director Education, whose sense and extent of involvement in all the Institute activities is really unparalleled and worth emulating. So I would also like to place on record my sincere thanks to Joint Director Research and Joint Director Extension for their help and guidance in the organization of this program. So thanks are also due to the Associate Deans, HODs, professors, faculty, students, staff, and all other guests who have attended this program. So in the end, thanks to the team of the Graduate School IARI for making all the necessary arrangements. Thank you, and all.
Thank you, sir. Thanks a lot, sir, for joining. We will request your, sir, kind presence off and on. But of course, sir, 15 days pre-time, we will just be in touch with you, sir. Yeah. Thank you very much. Sir, thank you, Director, sir, for joining and sparing your time. Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Thank you
sir.
all for joining. Yeah, we may leave. Sir, maybe now